Hi, BMIS 270 Part 4. We'll have an introduction to tcpip. We'll talk a little bit about what it is and how it's routed, and then a little bit of an explanation about how the project, your packet tracer project, will look. So here is a video about an introduction to tcpip.
This video is brought to you by Train Signal, your home for IT training products. In this video, we're going to go over tcpip and make sure that you have a general comfort level with what tcpip is and then how to configure it on a basic computer network. Now, tcpip you often hear a lot about, and you may be confused. It's sometimes referred to as tcpip or tcpip here, like you see without the slash, and sometimes just plain old IP. Now, when I say referred to, you may see this in a book, a technical magazine, or just talking to people in general. A lot of times people abbreviate what they're dealing with when we're talking about tcpip. Now, this is important to point out because tcpip is actually a whole suite or group of protocols. What that basically means is, instead of just being one individual protocol, this tcpip that we see up here is actually broken down into several protocols, including TCP and IP, as you see here, separated by the /. Now, some of the other protocols that are included in this suite of protocols are UDP, ARP, DNS, HTTP, ICMP, and really many more. Okay, there's several other protocols that are also included in the suite of protocols. Now, this collection of protocols works together to provide you that network experience that you're used to anytime you're on the internet or going back and forth in a network, even on a local area network. Now, tcpip was originally developed by the Department of Defense, but now the standard protocol is used in just about every network, including the internet. Let's take a quick look at exactly how tcpip works, just to give you a better feel, comparing it to our mail system. Okay? Now, up top here, what we're dealing with is just a normal sender who may be sending a letter through the U.S. Post Office. Okay, and then down below, we're going to look at this a little bit differently and just look at how it works within the computer framework. Okay, now we start off with our data existing on a computer, and that's what we have here. This data, when it's being sent across a network, is transformed into what we call a packet. Now, to get that packet from one computer to another, we need some way of addressing where this packet's going, and that's what we have when we use an IP address, which, as you see above, is very similar to a mailing address. Now, after we've IP addressed it, we then send it across the network, so it's electronically moving across our network as we see right here, and then eventually, once that packet has reached the destination computer, we have a confirmation packet that is sent back to the originating computer, informing it that we received the packet. Now, this may seem complex, but this happens over and over and over again every time you connect out to a website. Okay, so this process here happens transparently in the background many times as you're sitting there surfing the net or just even browsing on a local area network. Okay, let's go take a look at some hands-on information here. And what we're going to focus on is just a basic network diagram first off. Now,
and that video is quite a bit longer, but that's what we want to talk about, or at least introduce, is just in general how those packets and how are sent around the internet, how they're delivered. Okay, so when we take a look at, again, talking about tcpip, it's a set of rules to pass packets from one host to another. And one host in this case can mean hosts on a network, as in PCs, or switches, or routers. Okay, so all of those, any of those devices. So that IP address is composed of 4 numbers. Now, this is a good example here of a TCP/IP address. 192.207.124.1. It's 4 octets. Each one of those octets range from 0 to 255. Actually 0, because 0 is a network address. This is based upon binary. And so a binary 1 equals a decimal 1. This is a binary number. This is a decimal number. A binary 1111 equals a decimal 255. So IP addresses are comprised of decimals 0 through 255. And of course, the corresponding binary might look like 1101.001 dot, so on and so on. Okay, now what we'll do is, or what we want to talk about too, is public versus private addresses. Okay, so public addresses are IP addresses which are seen on the internet itself. Private IP addresses are those that you may see in behind a firewall on a local area network. Your network at home, you'll probably see IP addresses that might look like 192.168. something. Okay, at Helena College, if you look at the IP addresses on the computers in the computer lab, you'll see IP addresses that look like 10.10.48. something. So the private IP address you see in behind firewalls on local area networks. The public IP addresses you see on the internet itself. And remember, this IP address uniquely identifies a computer on the internet, and each device on the internet must have an IP address. Each device on the internet must also have a hardware address. An IP address is referred to as a software address. A hardware address is also like a MAC address, Media Access Control Address, and that's actually built into the hardware of your computer. It identifies the vendor and the serial number of the particular device that you're using. Your phone has a MAC address. Your phone has an IP address. Now, here's a short video on how routing works, and then we'll get into a little bit more of the details after that video. We'll take a look at the first 2 minutes and 31 seconds of this particular video.
The Transmission Control Protocol, or TCP, and the Internet Protocol, or IP, are two protocols used to move traffic between two nodes on a network. IP is very much like a transcontinental subway system. IP forwards data packets between nodes on the way to the packet's final destination. Some packets may not arrive because a backhoe cut a fiber cable or a node along the path crashed. IP uses best effort to deliver packets. That is, it tries to deliver, but doesn't guarantee delivery. If reliability is needed, IP assumes something else will guarantee that reliability, such as TCP. In a packet-switched network, the decision on where to send the packet next, once it arrives at a node, is called routing. The computer that controls where the packet goes is called a router. The decision of where to send the packet next is made separately for each packet entering the router, even when a flow of packets has already traversed the router between a particular source and destination. Imagine for a moment a subway system with all of the tracks being one line in each direction. Before you get in the subway car, you post a big sign on the front of the car that specifies your destination, such as Chicago. On the back of the car, you place a sign that shows where you are starting from, say, Atlanta. Once you begin your journey on the subway, at each intersection, a subway engineer looks at your destination and directs you to go down a certain track based on your destination, which is Chicago. If many of the tracks between Atlanta and Chicago are not functional, then you will be directed to Chicago via the only route that is open at the time, via Los Angeles. If the tracks are completely closed, then you will be directed to return home with the message that all roads are unusable. At some point you may get to Chicago, leave the subway car, and arrive at your destination. The router performs tests on the packet to ensure that the packet has not been corrupted or damaged and has remained intact along its path. The router then retrieves the destination address from the packet and performs a routing table lookup. When the router is doing the lookup, it is looking for the best match in the routing table for the destination. The router then hunts through all the entries in the table looking for the best match. A match is found and the packet is sent along the path to the computed best next hop. In the event that no match is found, then the packet is returned to the sender with an error. Many routing protocols are being used.
All right, so that's talking about how packets are routed. Now this also talks about how packets are routed. Let's turn on the pointer here. What we have is your source address, your source location. Okay, and this would be, I think it was Atlanta in the particular video. So this is A. Okay, now what happens is that packet, that information is all wrapped up with all kinds of stuff. At the application layer, the transport layer, this is where the IP address takes place, is wrapped up on this particular packet. Okay, at that internet layer. Now, at this layer, let's see, how do I want to say this? Okay, this point is right there. Okay, that point is right, and actually I should probably extend it right there. Okay, so it leaves this network and looks like this. As it enters this particular router, it's all packed up with all kinds of information in it. This router, though, at this point needs to unwrap that internet message enough to where it can go ahead and figure out what the IP destination address is. So we have IP, we're looking for the IP destination. That by definition is destination. So this router at this point has to unpack that message, figure out where it needs to go, and then at this point rewrap it, and then send it on its way. Now in this case what we're talking about is a best case or best effort delivery. So this router has determined, based upon the address, the destination address at point B over here, that this particular path, here to here to here, is the best way and the quickest way that that message is going to get delivered. Okay, so remember that each router will unpack, and see that a little bit better? Each router will unpack the message to this point, figure out where it goes, repack it, and then send it on its way. Okay, and that's what routers do. So it'll reach its point. Well, I wanted to say this: between Helena College and Yahoo, how many routers may there be in the middle of point A and point B? There may be 2 or 3. There may be 10 or 20. That happens. This process happens at each separate point on that path between point A and point B, between Helena College and Yahoo, for instance. Okay, this is also the case talking about these internal and external IP addresses. Private IPs can be used on the inside of a network. Okay, so that these boxes are listed as IP 10.10.10.1, 10.10.10.2. Now this point is also an IP address, a private IP address. It can be a private IP address, but the network actually ends at that point. So everything on the outside is actually public. Anything in this area has to be public IP addresses. Now at this point again, it basically separates there. This is a public IP address, and anything on the inside can be public or private. In this case, we have public IP addresses listed here. Okay, so once again, you can have private IP addresses on your network, like Helena College. On your router, where it goes out to the internet, that point where it hits the internet, it kind of is separated in two. On the inside part, you can use private IP addresses. On the outside, though, anything seen by the internet has to be public. Okay, and then this point is that you can have public or private on the inside of your address or inside of your LAN as well. So this is the internet here. Now, what we see in this particular slide is I just want to define some things for you. This is what your packet tracer assignment is going to look like. That assignment is where you build a small network and just basically get connectivity, and that's how any large network works. Whether it's small or large networks, they work the same way. So an IP address, remember, an IP address will, there we go, an IP address specifically identifies each device on your network. Now, a subnet mask tells the computer which part is the network and which part of an address is a host. because you want to define, you have to tell the router which part is a network, which part is a host. Okay. Now, the network address, it is, if I can find my little, there it is. The network address is the actual address of the entire network. Okay, so that's going to be the address that all of these other boxes are on, all these other points are on. The gateway, this address right here, is the point. This red line shows us what is our local area network. What are the components of our local area network? This is another local area network. Essentially, it's actually a wide area network because it's going across routers. And this is another local area network. This might be an example of Helena College and UM. Okay, so Helena College and UM. Now, what we see here, though, is the gateway. What we're talking about is the gateway. So this particular point is a gateway. A gateway is the point at which a local area network is connected to another LAN, WAN, or ISP. So this is that point when you're configuring your routers that is considered a gateway. So everything on this side has to go through this point to get out. Also, this is your gateway at this point. Everything on this side of the network has to go through here to get out. Okay, so hopefully, in addition to what we'll see within the assignment directions themselves that I'll go ahead and video, and I think I already have videoed, I'll go ahead and re-explain that a little bit further, but that talks a little bit about, this segment talks a little bit about what TCP/IP is and how routing takes place on the internet. So thank you.